Hello, today we're looking at organic reactions, and there are three types of reactions that we're looking at: elimination, addition, and substitution. First, we're looking at defining elimination reactions. So, elimination, sure you've heard of the verb to eliminate, means to take away or to remove. So in elimination reactions, a combination of atoms are removed from two adjacent carbon atoms. Adjacent means next to, and an additional bond is formed between the two carbon atoms. So if there was a single bond, after the elimination reaction, there would be a double bond. In this first elimination reaction, we're removing hydrogen atoms, and once you remove two hydrogen atoms and form the additional bond between them, the two adjacent carbon atoms, then we're going to form an alkene. So this is how we go from an alkane to an alkene, and it is by eliminating two hydrogen atoms. So it's a type of elimination reaction. In our next elimination reaction, we're going to be eliminating water. And water is H and then an OH group. So what we're going to be doing is we're going to be looking at our alcohol, where we've got an OH group on one carbon, and on the adjacent carbon, the carbon next to it, we've got a hydrogen atom. These are going to be eliminated and combined to form water, and instead of having the carbon bond to the hydrogen and the adjacent carbon bond to the alcohol, we're going instead to form a double bond between these two carbons. This elimination reaction is called dehydration. So dehydration means removing water. Dehydrohalogenation is a reaction that eliminates or takes away a hydrogen atom from one carbon and a halogen atom from the adjacent one. This example is an alkyl halide, also known as a halocarbon, to produce an alkene. So in the example that I have drawn, we can see that the halogen is an X, and it is on this carbon, and then we're going to take a hydrogen from the adjacent carbon, so that one would be nice. We're going to take them away, and they're going to form the hydrogen halide, and we're going to form a double bond here between the two carbons. So we're going to have gone from an alkyl halide to an alkene. Now we're going to move on to addition reactions. And in many ways, addition reactions are the opposite of elimination reactions. In an addition reaction, we're going to take a double or a triple bond, and we're going to break it and form bonds to other atoms instead. So this is an example, and it's called hydration. And a hydration reaction is when we're adding water. So we're going to have a molecule that has a double bond or a triple bond. The example in the picture is ethylene, according to UPAC known as ethene. We're going to break one of these bonds in the double bond, and instead of that, we're going to add a hydrogen to one carbon and a hydroxyl to the other carbon, forming a new compound, which, as you can see, is an alcohol, and this particular one is called ethanol. Hydrogenation is the addition of hydrogen. And again, we're going to have a double or a triple bond. In this example, we're having an alkene. So an alkene means a double bond. So when we have our alkene, we're going to break the double bond, and we're going to have looked that hydrogen is an H single bonded to another H, and we're going to have one of the hydrogens join onto one of the carbons that had a double bond, and the other hydrogen will join onto the other carbon. Once you've broken apart that double bond, added the hydrogens, we're going to be left with an alkane. Addition of a hydrogen halide, and this could be any hydrogen that is attached to a halogen, anything in group 17, and we're going to add this to an alkane with the double bond. Now, it is worth pointing out that there are slightly different rules as to whether or not it's a symmetrical alkene or an unsymmetrical alkene. An example of a symmetrical alkene, the simplest ones would be ethene. And when we add the hydrogen halide, HX for example, it doesn't matter because the both of the side groups, this group is the same as this group. It doesn't matter which carbon gets the halogen and which carbon gets the hydrogen because they're the same. So the halogen could join onto this carbon or it could join onto this carbon. It doesn't make any difference. However, when we have an unsymmetrical alkene, there are slightly different rules. So to the ethyl group, I'm going to colour in the purple, and the methyl group, I'm going to colour in blue. Now, this time, when we're adding our hydrogen halide, what we have to look at is the hydrogen gets attached to the carbon with the most hydrogens attached to it already. So we'd have a look at propene. Propene is not symmetrical. There is one carbon to the left of the double bond, but there are two carbons attached to the right of the double bond. So let's look at them and compare. This carbon has got two hydrogens attached to it, but this carbon only has one hydrogen attached to it. So according to those rules, what we're going to do is, because this carbon already has two hydrogens, we're going to add the hydrogen to this carbon and the halogen to the other carbon, which is why our picture is showing that this 2-bromopropane is going to be the more common product, because the hydrogen joined onto the carbon that already had more hydrogens, and the 1-bromopropane might form, but in significantly less quantities. In halogenation, we add a halogen, so not a hydrogen halogen, but an actual halogen. So we're going to have X2, where X could be chlorine, bromine, fluorine, or iodine. And we're adding it to a alkene. And because the halogen has the same atoms, chlorine, fluorine, bromine, bromine, and so on, it doesn't matter how you draw this, because you're adding the same thing to both of the carbons in the double bond. So we're going to be getting a, and we're going to be adding this chlorine and that chlorine. Although if you did it the other way around, it would still give you the identical products. The last type of reaction we're going to look at is a substitution reaction. Just like a substitute teacher replaces your usual teacher, in a substitution reaction, an atom or a group of atoms are replaced by a different atom or group of atoms. We are not adding or taking away bonds. So in our example of halogenation of alkanes to form an alkyne halide as a substitution reaction, what we are going to do is pick a hydrogen and we are going to substitute these two atoms. So this hydrogen will come over to where the chlorine is, and this chlorine is going to go over to where that hydrogen was, leaving us with chloromethane and hydrogen chloride. So there are no more carbon-carbon bonds or less carbon-carbon bonds than there were to begin with.